What is up, amigos? Today we have the aerodynamics of a taco, and here's a little secret just between you and me. If you put olives in your tacos, they are so much better. Like the black olives are better than the green ones, but they're all good. But you didn't hear it from me. So we have the aerodynamics here on the cut planes downstream, and the first thing that stands out to me is just how unsteady the wake is. Like even the very first plane is very unsteady, and it just goes chaotic downstream. There's quite a big wake as well, but it does die out quite quickly, which indicates that because it is so chaotic, that it's probably a lot of small scale structure stuff and not that many big, like large scale stuff. And that's why they break down so quickly. So these planes are the exact same ones, but they show the sub drag now. So the drag distribution along these planes. And you can see that the taco is very draggy. You can see like there are just big pockets of lots of sub drag. And I can tell you that the drag coefficient of this taco is 0.69, which is kind of eye-watering. I mean, I do like tacos, but are they worth having based on how the drag coefficient is so large? I don't know. We should probably put that into a poll. What do you think? So now we have a Y plane that's just encroaching into the taco region, and we can kind of see the same kind of thing as we saw with the X planes, where very close to the taco, the wake is incredibly big, and then as you go downstream, even like not even one taco length, the wake just sucks up so quickly. And that's probably because of this small scale structure stuff, but also maybe there's a lot of flow that just reattaches or like just sucks down into where the wake should be. So it's quite interesting, this wake. So this is the exact same plane, but now with the sub drag. And one thing that really stands out to me is obviously you have this massive pocket of drag, but then downstream you get these little pockets of drag that just like continuing downstream, and that's probably because of the von Kampfstreet coming off of the taco itself. So in this small scale, in this like region very close to the taco, that's probably where all the small scale stuff happens. Then as we get further away, the only thing that really survives is this large scale stuff, and it's even not that big because you can see that the wake is very small, the drag is very small as we go downstream. So we have a Y plane that's going closer into the taco now, so probably at about the midpoint range. And the bottom half of the wake is which we are seeing here, is very asymmetric to the top half. So you can see just how much bigger the bottom half is. That's likely because the bottom of the taco is quite smooth, so the flow does like come along there. Whereas at the top you have all the fillings and everything inside. So the flow goes over the top of the taco, then it separates over the front leading edge, then it hits all that stuff inside, and then the rear leading edge, and so it's getting turbulated a bit more, so that will probably help the wake on top stay a little bit smaller. That's why we have the wake on the bottom so much larger. Interestingly, the taco produces a downforce of minus 0.16, the downforce coefficient, the lift coefficient obviously, minus 0.16, so that means that it's getting sucked to the ground quite a lot, which is not great because when you're trying to lift it to your mouth, you obviously want it to come to your mouth as quick as possible, but this downforce is kind of preventing you from sticking it into your gob. So this is the exact same plane, but now with a sub drag. And we can see here that the lower half of this plane, that's where most of the drag is coming from. You can see the top half, as I mentioned, that's a smaller wake. So we have a smaller drag, and this indicates that most of the drag that we're getting is produced by the pressure difference from the front face to the back face. Not skin friction drag, no induced drag really. It's mostly just the pressure drag. So this plane now is on the very edge of the right side of the taco. And the wake is so much more chaotic here, and there's a lot more small scale stuff happening downstream. So that's sort of like medium range scale. I guess I have enough energy to be able to propagate downstream without, the viscous effects ripping them apart and dissipating the energy. So the reason why we have this is because we effectively have two edges of the taco that are quite well situated in the flow. So you have the front leading edge, and that's obviously you're going to have flow separation around that. But then the rear leading edge is sort of getting skipped over a little bit, but there's a little bit of flow separation around that as well. So that's indicating that there's probably this like two dual wake kind of thing happening, and that's why we get this a very messy wake compared to the other two planes that we just saw. Now we have a Z plane right at the base of the taco. It's just slicing through a little bit, and this is kind of what we've been seeing with the Y planes, where the very left part of the taco, like the one closest to us, we have the flow going over the front part, but it separates really only at the trailing edge. The leading edge doesn't have too much flow separation. That means we get this significant recirculation zone behind it. On the back of the taco, so the right side, like furthest from us, there is flow separation on the leading edge and the trailing edge. So that's why we get this like really convoluted wake happening there compared to the front and even the middle, where it's a lot crisper. And then that results in a lot more like chaotic motion downstream. This is the same plane, but it has a sub drag plotted now, and I can pretty much say with quite a lot of confidence that the rear half of the taco, so the right side, the one furthest away from us, is producing more of the drag than the upstream part, the one side closest to us, like that edge. And that's probably how the taco is situated. If you made the taco a little bit like pinched at the corners, that might help keep the flow a bit more streamlined and position it close more in line with the flow. This is a Z-plane significantly further higher up the taco, about midway, and really cool, the wake closest to us, like that edge, you can see it periodically, it sheds one vortex downstream. The other side of the taco should have a partner vortex, but it seems to be just like merged in with all the rest of the junk of the flow, so I can't really see it that crisply compared to the one that comes from the upstream part of the taco. So this is the same plane with the subdrag plotted, and again, I kind of feel like it's the back half of the taco, so like the part of the taco furthest away from us, that is producing more of the drag than the upstream part. What do you think? We have two Z-planes here now that's showing the wake of the taco. And amazingly, the one that's going just over the top of the taco, it has such a massive wake for how small the taco is at this point. Like the cross-sectional area is significantly smaller than the other Z-planes that we were seeing before. Yet the wake seems to be almost just as big. So the top part of the taco, we can say now, is very draggy as well. The other Z-plane, significantly above the taco, still has quite a big wake, considering that there is no geometry upstream. This is a three-dimensional effect coming from the rest of the taco. That is the end of this simulation. Make sure to like and subscribe, and let me know what you think about tacos. And in fact, promise me in the comments that you'll put olives in your taco next time. Promise me. Write it in the comments now. Okay, so that's the end of the simulation. Make sure to like, subscribe, and if you want to get better at CFD and or theory yourself, check out our courses in link description. And if you want to make your experiments 2% more accurate, check out Atmosphere Hawk. It's an instrument we make, link description, and I'll see you in the next simulation. Peace, amigos.